Okay, so we have a bearings problem here, and we want to find the distance of the starting point from an aircraft to the finishing point. So the problem reads that the aircraft flies 500 kilometers on a bearing of 100 degrees, and then 600 kilometers on a bearing of 160 degrees. We need to find the distance from the finishing point to the starting point. Well, whenever they give us a question like this, it's always going to be best if we draw ourselves a picture. Um, so I'm going to say that this is my starting point, and I'm going to fly 100 degrees. Well, remember, we always measure off of the north axis, so we always measure north. So for simplicity's sake, we're going to say that the top of the page is north. And when we measure our bearing, we always measure in a clockwise fashion. So if this is north, and I'm looking at 100 degrees, I'm not going to break out a protractor right now. I'm not going to measure this and do this perfectly to scale. This is a problem where it doesn't say to do a scale drawing, and we can actually figure this out pretty simply just by using some calculations. So what I'm going to do is I'm going to sort of estimate here. So if 90 degrees is like this, 100 degrees must be a little bit more, 10 degrees more, right? So I'm going to say that this is my bearing, and I go for 500 kilometers and to some point. So that's 500 kilometers. Now this point, which isn't important, I'm going to fly 160 degrees. When I measure my bearing now, I start over again. So at this point, I look north, and I say, okay, what's 160 degrees from here? Well, if 180 degrees is a straight line, so due south, 160, it's got to be 20 degrees less. So there. And I'm going to call this point F after I've flown 100 degrees on that bearing. All right, so now they ask us to find the distance from S to F. And now we panic because this looks like a very weird triangle to do any sort of trig on. I don't disagree with you. In fact, if I were looking at this, it might be more difficult to try and think of some more advanced trig than just doing some basic trig. So what I'm going to do is I'm going to give a whole bunch of right triangles out of this. We can make shapes from anything. We just have to make sure that we follow the rules. So here's where I'm going. And I'll show you what my plan is and what I envision, and then we'll take you through step by step. So this distance S to F, I can make a hypotenuse of a large right triangle. Now if you look at these two sides here, they look pretty difficult. Well, how do I know what they are? Well, I'm going to know what they are in time because I'm going to make two other right triangles. So here's one right triangle, here's another one. If I add their respective sides, they should equal the lengths of this triangle, and then I have dear old friend Pythagoras. But if that's too confusing right now, don't worry, because we're going to go through it step by step. So first up is I'm going to find out this smaller right triangle. So nice. And I need to find the sides here. Well, I know the hypotenuse is 500. So if I'm looking for side A, I can find this angle and it will help me. So if I know that I'm flying on a bearing of 100 degrees, this right angle here is 90 degrees. So 10 degrees extra is going to be 100 degrees. So that little angle in there is 10. Side A here represents the adjacent side, which is touching. So the adjacent side is represented by my cosine angle. So cosine of 10 degrees is equal to A over the hypotenuse of 500. I have a denominator there, so I'm going to multiply both sides of that equation by 500. And now I have 500 times cosine of 10 is equal to A. So now is where I'm going to use my calculator. You may have a different calculator, that's fine. Just make sure whatever calculator we use, we have it put into degree mode since we're using degrees. So I have 500 times the cosine of 10 degrees. And that gives me 492.40. So side A is 492.40. Now let's find side B of that triangle. Well, side B is going to be my opposite side, and my opposite is my sine angle if I still use that same 10-degree angle. So sine of 10 is equal to side B over the hypotenuse of 500. So I'm going to multiply both sides by 500, so I get 500 times sine of 10 is equal to B. Okay, so again, I'm going to turn back to my calculator, do 500 times the sine of 10, and I get this, 86.82. So B is equal to 86.82. All right, I'm going to put these in little boxes or highlight them just so that they stand out, and later on they're going to be easy to find. All right, so I'm done with this triangle. What I'm going to do is I'm going to make another right triangle, and I'm going to find these other distances. So I'm going to find side C and side D. And I'll do my work over here. All right, I need to find some angles here. So I'm going to look for this one. It's nice because I already know the bearing. Again, this bearing is 160 degrees from north. Well, if you look at these two sides, they do make a right triangle because I'm going due north and due east. So if that's 90 degrees, and this whole angle bearing is 160 degrees, this small angle must be 70. So if I'm looking for side C, which is the adjacent side, again I'm going to do cosine. So cosine of 70 degrees is equal to that adjacent side over the hypotenuse of 100. Multiply both sides by 100, a little bit of algebra in there, and put this in the calculator. So 100 times the cosine of 70, 34.20 is my side C. 34.20. And finally, side D. Well, side D is going to be the opposite side from this angle 70. So I have sine of 70 is equal to D over 100. I multiply both sides by 100, so I get 100 times the sine of 70 is equal to D. Okay. So 100 times the sine of 70, 93.97, I will say. I will round that. Okay. The hard part's over, believe it or not. So remember back to when I said we're going to make this a big right triangle? Well, I'm going to draw my sides here. It's a right angle. And if you look, this hypotenuse here, h, this is what I'm looking for. This is what I'm trying to find, this distance from start to finish. This side here, this top side, is made up of angle A, or sorry, this distance here, so side A, plus this distance, side C. That gives me this whole distance along here. So if I call this side X, X is really A plus C. And if I call this side Y, well, Y is going to be this distance D. Also, if I move this distance B up, it completes my side Y. So Y is equal to B plus D. So if we remember Pythagoras and his lovely theorem, he said a squared plus b squared is c squared. Yeah. To avoid any confusion with a's and b's and c's, which are already used, I'm just going to say that this is side x. And if I square that and add that to side y, that should equal side h. Right, so side x is going to be, again, a plus c. So 492.40 plus side c, which is 34.20. If I square that and add that to side y, which is b plus d, so that's going to be 86.82 plus 93.97. If I square this, this is going to be equal to h squared. So h squared is going to be equal to, I'm going to put this in my calculator now. So I'm going to get 492.40 plus 34.2. Notice I'm not going to do individual calculations. I'm just going to put this into my calculator using brackets and the different powers, the squares. I don't really care about the individual calculations, and if I don't care about them, they're not important. Honestly, they're just going to be a waste of time. So this is also going to help me with rounding as well. So I put this in there and I get this, 309,992.58. So h squared is 309,992.58. So that's h squared. So if I want to find h, I got to take the square root of both sides. So I put in the square root of that. And I get 556.77. So 556.77. And because they're dealing with kilometers, I'm going to put kilometers as well. Bear in mind, when I take a square root, yes, I do get plus or minus. However, since I'm dealing with negatives, since I'm dealing with distances, I can't have a negative distance, so I'm not going to put a negative distance as an answer. It's only positive 556.77. So I hope that going through this problem helped some. It's actually not a bad process. It looks like a lot, and yes, breaking it down piece by piece can be somewhat tiresome, but it's not overly complicated. If you look at the original blue triangle with this red side, that was really complicated. To try and figure that out, it would be really, really difficult. So we think back to easy trig. Well, easy trig is just right triangles. So I make a right triangle there, a right triangle there, and a larger right triangle. Using the sums of the sides and our dear old friend Pythagoras, we get the answer. All right, so I hope this helped. If you have any questions or want to see more examples, just let me know. All right, take care.